Alright, so welcome to Chapter 6, and this is the last section, I believe, of the Atmosphere section. And today, or this lecture at least, we're going to talk about climate change. So I know this term gets thrown around all the time. It's been in many of our conversations already, but today we're going to really dive into the science behind it. So let's start with some history. The Greenland Norse, the Vikings. So the Greenland Norse basically were Vikings that colonized Greenland between 950 and 1250 AD. They came from here, Norway, Scandinavia, eventually Iceland, and then Greenland. And we now have evidence that they even had, for a brief period of time, settlements here in Vinland. So if you remember your Leif Erikson day from Chicago Public Schools, if you were younger, this is in Canada. So they were actually the first Europeans to settle in North America. The Vinland settlement didn't last that long, but there were Vikings here, Greenland Norse, from about 950 to 1250 AD. Unfortunately for them, right after they settled, within 200 years, this climatic period we call the Little Ice Age, which was a cooling trend that lasted about 400, 500 years, basically put an end to their settlements. So here, when we look at the period right as they were settling Greenland, right about the year 1000, climate around the northern hemisphere gradually warmed. And so from the year 1000 to about 1300, for 300 years, it was warmer than normal, which allowed Greenland, which we think of today as ice, to be actually a little bit more green. And they settled there, they farmed, they had sheep, they fished, they traded walrus ivory, actually. Okay, but beginning in 1400, we have a period that is much colder. In fact, right here in the year 1600, in London, it would get so cold every year that the River Thames would freeze over. So much that they would have fairs with elephants on the ice. It doesn't freeze over at all today. So this huge thing, we think, basically is what ended the settlements, right? As it got colder, the ocean around Greenland began to freeze over every winter, and the ice became thicker every year. And what happens is, this made it harder for them to connect with Europe and Iceland to trade. They were never completely self-sufficient. They relied on importing some food in exchange for some of the walrus ivory and fish that they caught. And so what happens is, it also gets colder, it's harder to grow crops and livestock, and we gradually lose record of them. The last written record is in 1408 when they asked for a priest to be sent so that they could have marriage ceremonies. The priest was sent, we don't know what happened to him, and the next time Europeans come through Greenland is the 1700s, and all we find are their abandoned buildings, which are still there today. And so this is an example of climate change. We think of global warming, but this was climate change of a cooler nature and the dramatic effects it can have on human communities. So let's begin with, excuse my rubbing here, climate, right? So how come we can have cold winters like we've had in Chicago, but still have global warming, right? And the first thing is we have to understand there's a difference between weather and climate, right? Climate is the average of weather. Climate is the long-term trends. So when I say that I'm going to send you to Chicago, what are you going to pack for clothes? Well, the first question you're going to ask is it summer or winter? Because you know, generally speaking, if you come in summer, it's going to be pretty warm. You can wear shorts, short sleeve shirts, bring some sunscreen. But we can have days where it's really, really cold. Or we can have days it's really, really, really rainy. Conversely, if I said I was going to send you to, Chicago in the winter, you might want to pack, a coat and a sweater and boots. But there are days in the winter where we're still in the 50s or 60s. Generally speaking, Chicago is colder in winter and warmer in summer. That's weather. When we have a heat wave or a really, really cold day, that is weather. Climate is long term. Okay, so weather is what's happening at the moment. Is it sunny? Is it rainy? Is it dry? Is it wet? Climate is the average. What is the average temperature for May? That's climate, right? The average temperature. What is the temperature right now? That is weather. So look at this chart. When you look at the temporal scale, and I don't know why it says Temporals Cafe. When you look at the scale of time, if it's short, like hours, days, or weeks, it's usually weather. When you get into things like months or years or decades or millions, that's climate. So for instance, a hurricane is weather, the event itself. But hurricane season, that time from August through October when they happen, that is climate. I've always heard the good phrase, weather is your personality, climate is your personality, weather is your mood, if that helps. And you have to understand the difference. Here's a good example. San Diego and Tucson, Arizona. If you look at their average yearly temperature, 64, 69, their average rainfall, right, 10 inches, 11 inches, you could say, well, they must have the same climate. They must be exactly the same. But if you look at the bigger picture, you can see that those are differences. For instance, San Diego stays pretty level the same year round. The average temperature is 64, but it really doesn't get much colder than that or warmer. Whereas in Tucson, yes, the average temperature is 60 in the 60s, but you have a spike in the summer. Also, the rain average over the year, if you look at the last month of the year, August through December, in San Diego, they are very, very dry in the summer and a little bit wetter in the winter, whereas Tucson, it's different. So understand that the weather may look the same, but the climate's a little different, right? So what is the climate system? It's all these interactions between the different spheres. We've been talking about the atmosphere, right? But we do know that parts of the hydrosphere, oceans, interact with the atmosphere. Lithosphere, mountains, those interact with the ice. So it's all these different interactions. It's also the movement of matter with the use of energy, and those all affect it. But the big thing we've been talking about, and you basically, I don't know if you've not heard this in the news, and if you have, where have you been, is temperature increases. Some people use the term global warming and climate change interchangeably. Not exactly the same, but temperature generally is getting warmer. And what we mean by this, if you look at the average temperature anywhere on Earth, so you take all the temperatures we've measured since 1880 anywhere on Earth at the surface of the Earth. So the temperature here in Chicago, New York, London, Jakarta, Cairo, all of them, and you average them together, the average temperature of the surface of the Earth has gone up by 1.5 degrees since 1880. Now, 1.5 degrees Fahrenheit doesn't sound like much, but understand that's an average. Some parts have gone up much faster. Some parts have actually gotten cooler. But generally speaking, it's gone up. And that's the average temperature. And so that global warming is climate change, because remember, climate is the long-term average. And if the average temperature has gone up a degree over a century, or a century and a half, right, that is change. Climate has changed. The climate is now 1.5 degrees warmer. And as we're going to find, that also may include things like precipitation, wind patterns, all of that. Understand that extreme weather events of really big hurricane, like Hurricane Sandy or Katrina, that alone is not enough to change the average. What happens is you may have one really strong hurricane, like Hurricane Sandy or Hurricane Katrina, but if you have 2 more stronger hurricanes a year or 3 more a year, every year your average goes up. So what causes these things? Well, the first thing is a climate forcing factor. And these are things that change climate and aren't affected by climate. So they're independent of the climate system. In other words, volcanoes. A volcano will erupt where it is. It doesn't matter if it's cold, wet, dry, windy. It's going to erupt. The amount of energy we get from the sun, right? That affects climate. It doesn't affect climate, because the difference is a climate feedback. And these are things in climate that enhance a force. So for instance, the Ice-Albedo feedback, right? We've talked about this before. Ice and snow are white. They reflect light. So at the North and South Pole, there's a lot of ice and snow. And so a lot of sunlight is reflected because of that. That's albedo. And that reflected sunlight lowers the heat, because the heat isn't absorbed by the ground. It's reflected. And so the reflection makes it colder, and that cold temperature favors more ice and snow to form, which leads to more reflection, which makes it colder, which favors even more snow. And so that's a feedback, isn't it? Conversely, if the snow melts and the ground is exposed, it's less reflective, and the ground absorbs more sunlight and becomes warmer. And that warm ground helps ice melt even more, which means even more exposed ground, lower albedo, lower reflectivity, which makes it even warmer. So a feedback can go both ways. But that's affected by climate, right? This is not. And so that's an example, the ice-albedo positive feedback. If the ice melts at a faster rate, right, that means more open ground is exposed, and that destabilizes the climate system. It makes it warmer, and this leads to continually warmer days, which changes climate, right? Warming ice melts the snow, which means the lands and ocean absorb more sunlight, convert it to heat, and that heat warms more snow, and it kind of goes back and forth. Now, that's a actual, it's a positive feedback because it's basically adding to the climate system. A negative feedback, the opposite, could stabilize climate. So if something happens at the North Pole to allow more ice to form, that'll increase reflectivity, which will make it colder, favoring more snow, which will lead to increased reflectivity and less heat. So that can actually be a negative feedback. It can lower the amount of change. This is the positive feedback. And I got these wrong. So this is got these backwards. Ignore them. All right. We're going to pause right here while I get back and maybe try to edit that out. We'll see. I think you're all smart enough to figure that I got those backwards. And we'll see you for part 2.